Alright, for this last video, I have GeoGebra opened up, and this link is in the iBook if you want to investigate it yourself, or you can just watch me play around with it. But let's just read this a little bit. I'm going to switch up the screen sizes. If you draw the perpendicular bisector to each of the three sides of a triangle, the three lines all meet at one point. This is called the point of concurrency. So where they all intersect that's called the point of concurrency. It is also called the circumcenter of a triangle. All right, so that's what we actually been investigating and figuring out this whole time is a circumcenter. All right, and that was a circumscribed triangle. So using this exploration box, or from the iBook, we're going to explore stuff, and we're going to answer the follow-up questions. All right. So this is true for any triangle. Just to show you it's not the specific one that is already created. I'm making a random triangle. That's a pretty cool looking triangle right there. I'm gonna slowly slide this slide me bar. Look, so I don't know what just happened there. Let me go right there. That's perfect. All right. So let me pause there. These white dots, what are these white dots on each side? They are the midpoints of each side of the triangle. So those are midpoints. And these gray angles are right angles. All right, that's what they actually are. So that means that these red dotted lines are perpendicular bisectors. To each side. All right, and where all three dotted lines intersect is the point of concurrency. All right, and this particular point of concurrency is called the circumcenter of the triangle. So this is intense vocabulary right now, circumcenter. There's gonna be three centers we talk about in total. You got to know which one's which. Circumcenter is the one formed by the perpendicular bisectors. All right, now let's continue to slide stuff. All right. These blue segments, notice how they all have two tick marks? That means that they are equidistant. So this is what the big punchline of the circumcenter is. All right, this is incredibly important. The blue segments that is from the circumcenter to the vertex are congruent. They're all the same. So the circumcenter, this sentence is really important. The circumcenter is equidistant to the three vertices of the triangle. And we can even emphasize that here in a little bit. All right. And then we have this green circle. This green circle is centered at the circumcenter. All right. It's called a circumcircle. All right, and watch this. Like, this is for acute triangle. This is an acute triangle. What happens if I make it an obtuse triangle? Well, notice an obtuse triangle, the circumcenter is now outside of it. So when the circumcenter lies on the inside of the triangle is acute. When it's outside, it's obtuse. And then, like what we saw before, when it's on the side, it's right. All right. Now, let me see if I have a good picture down. Let me see what I want to do. We'll just write this down. Little star. Circumcenter is time out. Is equidistant to all three vertices, or you could call them angles, of a triangle. All right, so like say there's like three cities, you want to put something equidistant from three cities. This is a real life example. You'd use the circumcenter to place whatever you want, maybe a shopping mall or a hospital or an amusement park. And that's what's so important about circumcenters. It's equal distance from 3 points. All right.